Let's see some examples on gravitational potential energy. For 2-point masses M1 and M2 separated by a distance of r, we have developed gravitational potential energy as minus of G M1 M2 divided by R, provided M1 and M2 are point masses. At the same time, provided that this potential energy, which is represented by U R, when you are at infinity, it is what? Zero. At infinity means when separation between M1 and M2 is infinite, then U is what? Zero. Now the question is, we have got 3-point masses, and these 3-point masses, they are forming an equilateral triangle of side length L. There are identical masses M, 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 forming an equilateral triangle of side length L. We need to find potential energy of this system, potential energy of this triangular system, gravitational potential energy. Now, when you say that gravitational potential energy of 2-point masses is minus of G M1 M2 divided by R, this potential energy is of the pair of M1 and M2. From the derivation of gravitational potential energy, you know that it is coming from action and reaction forces. So, for action and reaction, you need to have what? A pair. How many pairs do you see in this figure? M, M. Potential energy will be minus of G, M, M divided by L. Now, many times people go for L square, a silly mistake, that is force. For potential energy, it is what? Minus of G M1 M2 divided by L. Then I told you how many pairs you can see. One is this. That's your first pair. Potential energy of this system is this. Then, that's your second pair. Its potential energy is also what? Same. Then you can see the third pair, and therefore potential energy of the entire system is coming minus of 3 GMM divided by L. Now note down this and then find out potential energy of a 4-mass system. There are 4-point masses, 4-point masses forming a square of side length L. You need to find potential energy of the system. System means you need to consider all 4 masses. Note down the first example. For this one, pause the video, try it yourself. If you cannot, come back and see the solution. Now, once you find a system like this, then mostly people will go for this. They write U as what? For a triangle there were 3, for a square there are 4, and therefore they straight away go for minus of 4 GMM divided by L. And then they think that the answer is complete. But no, this answer is not complete. How do you complete your answer? How many pairs do you see? This is the first pair. This one. Then the next one. Then the next one. Then the next one. And then there are two like this one and this one. Once I do this, you will think that okay, there are 6 pairs, and therefore let's go for minus of 6 G M M divided by L. But again, this is wrong. Why wrong? Because this and this diagonal pairs, for these two, separation is not L, but is what? You know the length of the diagonal of a square. It's what? L root 2. And therefore, the correct answer is you will find potential energy in this form. There are 4 identical pairs giving you a potential energy of 4 gm square divided by L. And then you've got two pairs with separation L by root 2. Sorry, L root 2. L root 2. That gives you potential energy of this system. Now, as a trick, just remember that if they give you n number of particles, n number of point masses, then you must have n into n minus 1 divided by 2, these many pairs. When we had 3, this is 3 into 3 minus 1, which is 2. That is, total number is coming what? 3. When you've got 4 particles, your n is what? 4. This is 4. This is 4 minus 1, 3. 4 divided by 2, that is 2 into 3. It's coming what? 6. So at least you will get an idea that you must have these many pairs. Now remember, these many pairs, they may not be identical, because in this setup you can see that 4 are of one type and then 2 are of the other type. So if you have got n number of particles, n number of point masses, then remember that you must have these many pairs. Note down this one, and then we'll see the next example based on this thing only. But first, note down this much. Now, this example will let you know the importance of potential energy function. Why do we develop it? Look at this. Suppose we have same triangular setup, 3 masses m, 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 forming an equilateral triangle. Same setup. Now, we have already done a question like this, in which this m and this m, they exert some force on this block, and this m is pulling this m towards itself. This m, it produces a force in this direction, and because of these two forces, you get a resultant force in this direction. This is the resultant force which is acting on this. Now, similar to this F total, and F total is present on this mass also. This is being pulled. This is being pulled in this direction by this block, and also in this direction by this block. This is action, this is reaction. Resultant of these two is also what F total, and same F total is present on this. Because this M is being pulled in this direction, action and reaction, and also being pulled in this direction, action and reaction. This M pulls this M, and this M pulls this M. F total, F total, F total. These are what resultant forces which are acting on this M, and this M. Now, question is that initially all three masses are at rest. All three are at rest. And then you release these three masses. Once you release them, because of the presence of F total, these three masses, they will start moving in this direction, in this direction, in this direction. Now, since all these forces are identical, what will happen after some time, this shape will remain triangular, will remain an equilateral triangle, but its length will reduce. So what happened? It started with this. That was the initial setup. And then after some time, you found that they are present at these positions. You got a smaller equilateral triangle. The original one, its length is L. But after some time, due to these forces, these masses, they come closer and they form an equilateral triangle of half of the length. This length is now L by 2. When this length is L by 2, question says that because of the force, all these masses, they have developed some velocity. And we need to find that velocity. Because of this force, this M, as it comes down, it will gain some velocity. Similarly, this M and this M. So when this triangle, its length reduces to L by 2, this thing is moving in this direction with some velocity v. And if you can see the logic, this one will move with v, this one will also move with v in this direction. This one will also move in this direction with v. Initially, all three are at rest. You need to find this v. Initially, all three are at rest. You need to find what? V. So, at this stage, pause the video. If you think you can answer the question, then go for it. If you think you cannot, then look here. If somebody tries to answer this question with the help of v square equals u square plus 2as, they go and find the displacement and all. If you go and use these equations, v square equals to u square plus 2as, then you cannot use these equations. These are Newton's equations of motion and they are used when acceleration is constant. If you look at the initial moment, then these forces, this force is what? G m square divided by L square. And as they come closer, this force is continuously changing. In fact, is increasing. If F is increasing, this is also same F. This angle is 60, and therefore F total you can easily find by taking components or by using the resultant force formula of root a square plus b square plus 2ab cos theta. The point is that this F total is also a function of what? L. And this L is continuously changing. If L is changing, force is changing. If force is changing, then acceleration is changing. But this equation is used only if acceleration is what? Constant. And therefore, in this question, you cannot. Then the other thing is, find out A and then go for dV by dt. This approach is valid, but is very lengthy. You will need to find force as a function of x, and then you have to integrate, put some limits, and then finally you will get the answer. Now, let's see the advantage of potential energy function. Why do we develop things like these? So the question says that somebody is holding these 3-point masses. They are forming an equilateral triangle. Everything is at rest. And then the person who was holding these 3 masses, he released all 3 together. And once you release all 3, they start moving in these directions which you know. And ultimately you need to find what? V. Now, the moment you say that they are released, that means the person who was holding these 3 masses, he is gone. And once he is gone, you know that F external on the system is what? 0. These are internal forces. Action and reaction. These are internal forces. Somebody is holding this M to balance F total. Now once that guy is gone, because of F total, this M starts moving. These forces, they are what? Internal forces. You don't have to worry about internal forces. Important thing is that the moment you release the system, F external is 0. And if F external is 0, you can see that W external is also what? 0. And if you say W external is 0, then we use what? COME. Conservation of mechanical energy. There is no external force. Internal is there. You don't have to worry about that. There is no external force. Work done by external force therefore is 0, which means you can conserve mechanical energy. What is mechanical energy? Sum of kinetic and potential energy. So what you are seeing is that kinetic energy initial plus potential energy initial is kinetic energy final plus potential energy final. Now, what is initial kinetic energy? 0. Rest, rest, rest. All 3 are at rest. What is initial potential energy? Look here. What is this? Gravitational potential energy when separation is what? L. Initially separation is what? L, and therefore initial potential energy is coming 3 gm square divided by L equals to, what is final kinetic energy? This half mv square, this half mv square, this half mv square, that is 3 into half mv square. And what is final potential energy? What is the side length of equilateral triangle finally? L by 2. We have found gravitational potential energy when side length is what? L. So when it becomes L by 2, you will be simply saying what? Gravitational potential energy finally is 3 m square divided by, replace L with L by 2. In just one line, we have solved everything. You don't have to use any integration. You don't have to worry about whether acceleration is constant or not. Just we know that there is no external force, there is no external work, and therefore mechanical energy can be conserved. This is the advantage of developing potential energy function. If we do not do this, then question can be done, but mathematical difficulty that increases. Now, put on this, and as a practice, same question, the square one. For that square one, also find out what velocity when length of square reduces from L to L by 2. Put on this and try to solve that question. Now look at this next example. We did a question in which we had a circular ring, and I asked you to calculate force of this circular ring on a point mass m, which is placed on the axis at a distance of x from the center of the ring. Radius of the ring is r. This m is the ring mass. This m is your point mass. Now, question is that this ring mass is fixed. It cannot move. It's a fixed ring. And this m is free to move and initially is at rest. Now we know that this ring is going to attract this m towards itself with a force of F, and I hope you remember the force. This force was coming G M M X divided by R square plus X square to the power 3 by 2. That was the force which acted on this M at a distance of x from the center. And because of this force, it moves in this direction. The question is, when it reaches center of the ring, it has gained some velocity v. This m, when it arrives at the center, its velocity is v. Velocity of ring is fixed. We need to find this v. Hopefully question is clear. If you think you can answer the question, then pause the video and try it. Otherwise, look here. Take the hint, and then after taking the hint, you can again pause the video and maybe you can solve the question. The first thing, if somebody goes for v square equals u square plus 2as, then that is not valid. That's not repeated again and again, because you can see that your force is a function of what? X. It's continuously changing. As it moves towards the center, x changes. Because of changing x, your force changes, and therefore we cannot use Newton's equations. You can always go for A as dv by dt. That's your force. You can divide this force by mass, and then you can go for integration. If you think you're good in integration and all, go for it. That will give you an extra edge. If you can integrate this and get the final result, that will improve your mathematical abilities. If you find any problems in that integration method, you can discuss that with me. But we are not interested in integration and all. We are interested in the concept of gravitational potential energy. So, this ring is fixed. This M is released and it starts moving towards the ring. F external this time is not 0. F external is not 0. But W external is still 0. Now take your time, think about it. What is happening? When I say that on this system of ring and point mass, external force is present even when you release this M. It's free to move. The moment you release this M, it starts moving, but still an external force is present. Even though that external force is present, W external is what? 0. Maybe you've got the idea why W external is 0. Look here. There is an external force who is holding this ring at this place fixed. Somebody is holding the ring. If you keep the ring fixed, to keep this ring fixed, you need to apply constantly an external force. Otherwise, what will happen? What is this force? This force is this. This is force of the ring on the point mass. And if I ask you what is force on the ring by the point mass, then what? Action and reaction. Same force is also present on the ring. Same force. To balance this force, you must apply an external force. Look here. What is happening? That's your ring. Let me show the force as if it's acting here. Force F is basically acting on the ring itself, but we can take that as if it is acting on the center of mass here. This is your M, F, F, and F acting at the center of mass. These two are internal forces. Internal. Action and reaction forces. At the same time, there is an external force in this direction. And this external force is always equal to F. Then only you can keep it what? Fixed. If this is 10, this is also 10. If this is 9, this is also 9. Force is continuously changing. But whatever this force is, same as this external force, because you are keeping your ring fixed. Now the problem is that external force is present. So people think that if external force is present, there must be some work. But then again, look here. What is this? Fixed. Fixed means no displacement. There is no displacement present in the ring, and if there is no displacement, you know that work will be what? 0. Whatever be the force. Since there is no displacement, W external on the system is 0. Hopefully you understand the meaning of this point. And once you say that W external is 0, you can go for COME, conservation of mechanical energy. Now, you can pause the video at this point. If you could not solve it, that's the hint. Take the hint, try to answer this question. Now, when we go for COME, we'll be using kinetic energy and potential energy. So we'll write kinetic energy initial, potential energy initial, kinetic energy final, and potential energy final. This is gravitational potential energy initial, gravitational potential energy final. Kinetic energy, you can see initially is what? 0. This is free to move, but initially is at rest. Ring, it doesn't move, it's always fixed. We need to find potential energy. Finally, kinetic energy is what? Small m, it has reached the center, it's moving with v, its kinetic energy is half mv square. If we can find potential energy initially and finally, then we can handle this question. So, how do you handle this question? Potential energy, you know that, is minus of G M divided by, when separation is x, potential energy will be what? Minus of G M divided by x. Separation between ring and point mass is what? X. But this is wrong. What is wrong with this? What is wrong with this? Think about it. When do we use this formula? We use this formula only when both this body and this body, they are what? Point masses. But in this example, only small m is what? Point mass. Ring, it's not a point mass. And therefore, I cannot use this formula. So if you cannot use this formula, then what is the formula which you should use? Again, a very easy task. We need potential energy of ring mass m with point mass m. Ring mass m with point mass m. That's what the aim is. Now, same concept. The concept of force which we used to develop this whole function. What was that concept? You can always break your ring into small point masses. Now, all these point masses, their distance from small m is what? Root over r square plus x square. This is r, this is x. What is this? Root over r square plus x square. Now, when we needed total force, we had to use integration. We had to resolve all the forces which were coming on this point mass from all the point masses present on ring. We had to resolve all those forces along the axis, perpendicular to the axis, force components, they got cancelled, and only along the axis components they survived. Because we were dealing with force is what? Vector quantity. Whereas in this question, we are dealing with potential energy, which is a scalar quantity. And therefore, we can find potential energy in just one line. What is that one line? Potential energy of this system when separation between center of the ring and point mass is x is not this, but is minus of Gmm divided by root over r square plus x square. Every point mass on the ring, its distance from small m is what? Root over r square plus x square. and therefore, if you write all these things in this form, if you take first point mass as m1, second point mass as m2, third point mass as m3, m1, m2, m3, they are what? Point masses. Capital M is what? Ring mass. These point masses, their distance from this point mass is root over r square plus x square, and therefore potential energy should be minus of g m1 m divided by root over r square plus x square. Then you will go and write minus of g m2 m divided by root over r square plus x square plus. Ultimately, you can see that you can always take g m and the denominator common together with the negative sign, and ultimately what is left inside? m1 plus m2 plus m3 plus m4. All these masses, ultimately that will give you what? Capital M. So in just one line, remember what? Each and every point mass of the ring is at same distance of root over r square plus x square. And since potential energy is a scalar quantity, we can directly sum all the potential energies in this form. That is potential energy of a ring mass with a point mass placed on the axis. The moment you develop U, question is done. What is U initial? U initial is coming minus of G M M divided by root over R square plus X square. And finally when small m is at the center, your X becomes what? 0. X becomes 0. This is only what? R. Potential energy is coming minus of G M M divided by R. Again, something very easy, you don't have to use this formula. If your point mass is at the center, the moment it is at the center, its distance from every point mass on the ring is what? R. And therefore potential energy once small m reaches center is minus of gmm by R. Shift and you will get what? V. Note down this. It's an important profile conceptually also, because it tells you so many things that you can use integration if your mathematical abilities are good. If they are not, develop them. It's not a difficult integration. If you find it's difficult, take hint from my side. Ultimately you can. But in school examinations and in competitive examinations, you don't have to use that integration. You can simply use what? CONE. For CONE, remember, you need to go for W external 0. F external, it can be 0, it can be non-zero. Ultimate thing is that if external force is present, then it should not do any work. If it doesn't do any work, we can use CONE. Note down everything.